Hello everyone, my name is Praveen Barode, branch CAC AIML. Today's topic is probabilistic reasoning of artificial intelligence. The definition of probabilistic reasoning is that deals with uncertainty by using probability theory to represent and reason with uncertain knowledge. Why it is needed? Real world information is often incomplete or noisy. Deterministic logic is insufficient for uncertain environments. These key concepts are random variables, prior probability, conditional probability, and posterior probability. Now, Bayes' theorem. Bayes' theorem provides a mathematical way to update probabilities based on a new evidence. Bayes' theorem formulas is posterior probability equals to likelihood multiplied by prior probability divided by evidence probability. Here example is probability of having a disease given a positive test result. Now semantic networks. Semantic networks represent knowledge as a graph of nodes and links. These components are nodes equals to objects or concept. And second one is links. Link represent relationship. For example, canary is a bird. Bird can fly. These advantages are easy to understand, supports inheritance. Semantic networks, its limitations are cannot handle complex logic well, weak formal semantics. Scripts of probabilistic reasoning of artificials are script. Script represent stereotypical sequences of events in a specific context. For example, restaurant script. Here, enter the restaurant, now order book, then eat, pay bill, and leave. These uses are natural language processing, understanding stories, and predicting events. The limitations of script is not flexible for unusual situation. Schemas of probabilistic reasoning of artificial intelligence. A schema is a structured framework representing general knowledge about objects or situations. The example of schemas is classroom schema. Here, entities are teachers, students, blackboard, and desk. The features of schema is helps organize knowledge, guides perception and understanding. Frames of probabilistic reasoning of artificial intelligence. Frames are data structure for representing stereotyped situation. The structure of frames, slot like attributes, fillers like values, default values allowed. The example of frames, bird, wings, yes, can fly, this is true default. The advantages of frames supports inheritance, handle defaults and expectations. Conceptual dependency of probability reasoning of artificial intelligence. Conceptual dependency theory represents the meaning of sentences using conceptual primitives. The goals of conceptual dependencies eliminate ambiguity, represent meaning independence of language. The example of conceptual dependency are John gave Mary a book. Utterance John, book, and Mary. Primitive actions adherence, transfer of possessions, pedilance, physical movements, and emptiness, transfer of information. Forward reasoning or probability reasoning of artificial intelligence. Forward reasoning starts with known facts and applies rules to infer new facts until a goal is reached. The characteristics of forward reasoning is data driven, used in expert system. Example of forward reasoning is facts, rules, and conclusion. Backward reasoning or probability reasoning of artificial intelligence. Backward reasoning starts with a goal and work background to see if known facts supports it. The characteristics of background reasoning is goal driven, used in a logic programming. Example for prologue. The examples of backward reasoning is goal, required facts, and check knowledge base. The comparison of forward and backward reasoning in artificial intelligence. Here the features are approaches, start point, efficiency, and example use. In forward reasoning, the approaches are data driven and backward reasoning is goal driven. And start points in forward reasoning is known facts and backward reasoning is goal. Efficiency with in forward reasoning good for many conclusions and backward reasoning is good for specific goals. The example uses are forward reasoning in monitoring system and backward reasoning is diagnostic system. Thank you.